This video is going to cover influence lines. Here we have a simple beam that's pin and roller supported and also has cantilever ends. And we want to find the influence line for the vertical reaction at B and the internal moment at C. So we're going to do two separate problems here. We have the pin 6 feet from the left end. We have point C in the middle between A and B. And then we have a cantilever end that is also 9 feet past B. So how influence lines work is that we're putting an imaginary point load on our beam of value 1, and then we're going to move it across the beam. So we're going to effectively do just statics multiple times. We're going to just set up multiple different problems, the same problem, just with one load being moved. So this is going to be our first loading location at that cantilever. Our second loading location is going to be at A. Because we want to find internal moment at C, we're going to load at C. Our fourth one's going to be at the roller, and our fifth one is going to be over at the other end of the cantilever. So we're effectively going to solve 5 different problems as we move our load across the beam. So first up, let's start by just drawing a diagram of what's about to happen, and we'll see how this is going to play out. So at A, we have AY and also AX, and at B we have BY. And to start with, we also have our point load over here at the end. Now we want to solve for the vertical reaction at B, so technically we want BY. So just looking at this free body diagram that we just drew, if I want to find BY, I'm going to sum the moments about A. So I'm going to sum moments about A and set it equal to 0, taking counterclockwise to be positive. That means that both of these don't act there. How very convenient. So first up, we have our point load of 1, and he's going to be going in the positive direction, so it's 1. Times the distance, we'll have to look above for that. That's going to be 6 feet. Then we have point C here, and that's going to be 9 feet. 9 feet, 9 feet, just to enhance our free body diagram. So 6 feet for us from that point load to A. Then we have BY. BY is going to be also going in the positive direction, so plus BY times his distance of 9 plus 9 is 18 feet. So that gives us a BY value of negative 0.333. Next, what we're going to do is we're going to unload that and then move the load to our second location. So at our second location here, again, we still want to find BY, so we're going to, again, sum the moments about A and set it equal to 0. So we have our point load times the distance of 0, and we have BY times the distance of 18. So BY is equal to 0. And then if we unload it and reload it again, this time at C, we get for our third spot, if we sum the moments at A and set it equal to 0, we have, taking counterclockwise to be positive, we have our unit load of 1. He's now, though, going to be going in the wrong direction, so negative 1 times the distance of 9 feet plus still BY times 18 feet. So BY is going to equal 0.5. Then, if we unload it and load it now at spot 4, do the same thing again, sum the moments about A, set it equal to 0, taking counterclockwise to be positive. We have negative 1, that's our point load, times 18 feet, plus BY also times 18 feet. So BY equals 1. Lastly, we're going to unload it from that spot, move it on to 0.5. So we load it over here. So at spot 5, if we sum the moments about A and set it equal to 0, taking counterclockwise to be positive, we have -1 times 9 plus 9 plus 9, that's 27 feet, plus BY times 18 feet. So BY is going to equal 1.5. And all we have to do is plot that now for our influence line at BY. So we are going to plot, we have BY, we said -0.333. At spot 2, we said it was 0. And then at spot 3, ooh, this is going to get a little bit nasty there. Technically, he's going to go like that. This is -0.333. This is 0. This is 0.5. This is 1, and this is 1.5. So that's our influence line for B. But we said we also wanted to draw an influence line for the moment at C. So in order to do that, how do I find internal moment at C? Well, I'm going to make a cut at C. So I need another free body diagram. So this one's not going to be as glorious. We've got BY right in the middle of it. And we have 9 feet on each side. And that's going to give us internal moments at C. Technically the shear, the normal, and the moment at C. So what we're going to do is start our problem effectively all over again. We're going to come over here to spot 1 and place our load. Now, BY is not changing, so we can actually use all of this information that we currently have for BY over in our free body diagram. And all we need to do is sum the moments at spot 1. We're going to sum the moments about C. Set it equal to 0. So if we sum the moments about C, we've got moment at C going the wrong direction, so minus MC. We got BY going in the positive direction, so plus BY times 9 feet. So what was BY? Let's just go plug him in. BY at spot 1 was -0.333. So if you plug that in, we're going to get that moment at C. Maybe we're going to run out of space here. We're going to get that moment at C is equal to -3. So then we've got to unload it and then reload it at spot 2. Now, he's not appearing on my free body diagram past the cut because he hasn't made it that far yet. So again, we're going to sum the moments about C and set it equal to 0, taking counterclockwise to be positive. Again, we have minus moment at C plus BY times 9, where BY this time is 0. So moment at C is also 0. Now we're going to unload it, and we're going to reload it at the cut. Now, since we're solving for the moment at C, it does not actually matter, but technically we want to load it just to the left side of the cut and then again just to the right side of the cut. That's not going to change BY in the slightest, but it would mean at the beginning he wouldn't be acting at this point, and then all of a sudden he would be here. But since we're going to be taking moment about C, either way, he's not actually going to be contributing to our moment equation here. But if you were, say, solving for shear at that point, you would want to take the cut just to the right and left and load it that way. So at spot C, we're going to sum the moment about C, set it equal to 0. And we're going to have minus MC plus, again, BY times 9. This time, BY we have as 0.5. So we're going to get that MC is equal to 4.5. Then we need to unload it. And we're going to reload it, this time at spot 4. Spot 4 has finally made it onto our free body diagram, right? We're finally past the cut. So our equation is going to change just ever so slightly here. So at spot 4, we're going to sum the moments about C, setting it equal to 0. We've still got negative MC. We still have plus BY times 9, but we also have this 1 going in the wrong direction, also times 9. So that's going to cancel out, and moment at C is then equal to 0. Fun. Then we've got to unload it, and we've got to reload it one more time at spot 5. And that's, again, finally on our free body diagram. So at spot 5, we're going to sum the moments about C and set it equal to 0, taking counterclockwise to be positive. We have negative MC plus BY times 9. That still hasn't changed, but this time our 1 load is at a distance of 18 feet. So we're going to get, when you plug in BY was 1 here, BY is 1.5 here. When you plug that in, you're going to get that MC is equal to negative 4.5. So going to plot that out, we have a negative 3 and a 0, and then he's going to go all the way up to 4.5. And then he's going to turn right back around and go down to negative 4.5, passing through the 0. So we have 3, 0, 4.5, 0, and negative 4.5. So effectively for influence lines, you're just solving the same problem of statics multiple times, just moving the load each time.